ReasonConf is brought to you by our gold sponsors, Ahrefs and Chain Street.
Welcome again to ReasonConf. This talk is going to be about 1 hour long, so I think you guys and gals are going to get bored halfway through. So why don't we start with a little game, right? So this is Rings, the iOS and Android game, award-winning game. We're just copying it, and the template is provided by Vincent Reamer. And I have my mouse here. And what we're going to do is I'm going to give you the updates, and you're going to read through this thing and raise your right hand if you want me to swipe right, and raise your left hand if you want me to swipe left on this, okay? So first item is there's this architectural astronaut in the team, right? I am the CEO, apparently, and I have the balance between the product, right, and the finance and the happiness of the general cohort. And the architectural astronaut comes and says, "I thought about it a lot, and I think we should adopt a new programming language called Review. It'll really increase our productivity." So right or left? I think that's mostly right, so I'm going to go here, right? Like, yes, okay. So I guess it affects product and happiness, but we don't know in which direction, better or worse. I hope it affects it. Oh, nope. It just, yeah, happiness went up, the product kind of went down. You kind of, I guess you're building up inertia, right? So you know how this works now. Okay, I'm going to get actually a little bit more serious. We've been a little bit more silent for the past year regarding the updates, and this is partially intentional, partially unintentional. First of all, the best way to keep yourself up to date is on this the blog post that we publish and Discourse, not Discord, Discourse, the non-ephemeral way of communicating news. For the recent syntax, we're going to post a little bit less about it because, it's a syntax, right? BuckleScript update will come, hopefully in a bi-weekly basis. So I think that's the major thing we're caring about right now. And speaking of BuckleScript, BuckleScript 5 and 6 simultaneously are out today, or a little bit before that. So BuckleScript 5 doesn't have many breaking changes. Well, we don't know of any major ones. BuckleScript 6 is released at the same time because we finally caught up to OCaml 4.06 after a long time. So who is excited for BuckleScript 6? Yeah? Who's excited for the new Game of Thrones? Yeah, I can see your priority here, All right, let's keep going, right? Reason React has a fantastic new release done by Ricky Vedder, one of our teammates. Actually, you know what, let's go do this. The product engineer comes and says, "This new language is killing my productivity. Can we push back a little bit?" Yeah, that's a little bit unexpected. That never happened. So do we push back or not? No? Huh. I wonder why at this conference. Let's not push back, okay? All right, who's that person? Manager. All right. We're so understaffed, we need to hire more. Yes, no? No? Do you see the product is kind of like a yes, no? Should be a yes, right? I'm going to pick a yes because you folks shouldn't be managers. All right, let's pick a yes. Okay. And the CFO says, "Our product isn't selling, we have to fire everyone." Okay, well, nope. No, just I guess we died. So let's keep going. Reason React, fantastic release. I'll be talking a little bit more about it very soon in the context of what I'm actually going to talk about seriously. Again, it's done by Ricky, and if you folks have any idea how elaborate a release can get, it's insane. But it's very easy to let the quality slip when you do a release like that. It has been in the work for a few months now, and Ricky fortunately has resisted letting the quality slip. Okay, and we're going to also try to put a little bit more emphasis on Belt, the standard library for BuckleScript. The data structures there are very amazing, and we definitely need to write more about it and write more about why you should use this versus the alternative on why not. there are lots of insight to be gained from these data structure, even when you just console log it. And pushing about harder also means having better documentation for it. So we're going to actually work on the about documentation for real. Now the async story. This is so sad. Let me just do this again. Wow, there's a designer. Well, there's another round. So async story. This is a little bit of a embarrassing and hard to explain one. People are expecting us to have some sort of feature for async await, right, or like some monadic whatever for sugar for these kind of pipelines. We haven't decided yet, and it's weird to say, but we kind of don't want to decide now, and we kind of want you to still keep using callback a little bit. It's not sacrilegious. Your product is going to be fine. There are way more things that are going to kill your product than a few callbacks. And the reason is async await is actually a nice pattern, but we don't think so on the front end. Even the React.js team has expressed regret to model, for example, suspense as a promise because the semantic just doesn't align, and it's always asynchronous, and then you get some weird flashes in your UI because something is deferred asynchronously instead of synchronously, and there's just no way to go back, right? And that's a little bit rough. All right. And let's finish this up and get a little bit more serious. Okay, designer, we need new animation composer 17 spring. Someone is trolling me. I can't do fewer springs, I'm sorry. So yes or no? Let's have more animation, please. Please say yes. Okay. Okay, product engineer, I like to go to a conference. No. so yes or no? No? There's no money. You folks should hire this person. Smart, very smart. There's no more money, so this is a no. Sorry about that, but we're probably going to go bankrupt. Okay, CFO says we're running low on money. Let's raise another round of funding. Yes or no? Yes, funding or no? No funding? Yes. This is taking too long. I'm gonna keep going. Okay, well, product engineer says, actually, the new language isn't so bad. Look at that. Look at that. What do we say to that? Yes or no? Yeah? I'm going to say yes to that. And no idea. Sometimes life is just like that. You start up kind of just does the thing it does and doesn't depend on the language really. Okay, the designer, we really need to have a consistent design across all apps. Yes or no? Yeah. Who said no? Okay. You know what? I'm not gonna play this anymore. This is kind of getting boring now. So let's start the actual slide. If I can find my mouse. There we go. Today's topic is a little bit more serious than that. It's titled Cost Analysis, and this is very relevant to what we're going to talk about. And again, I want to thank all this organizer for this. Again, for this second year. This is a tremendous amount of work, so let's give a round of applause for them. Technical update is already done, so I'm going to skip it. I want this talk to be a little bit more about like these kind of cost analysis and system level thinking, because too often do we discuss about technology and miss the forest for the tree, and especially in a functional programming language where the attraction is really the language itself. And I would like to also provide a few real-world examples of how to think at the system level rather than the individual piece level. And we will see somehow how sometimes a naive decision that makes sense in taking isolation doesn't make sense for the whole. This talk is going to be divided in 3 sections. First section is math. This is why I started with that game, because if you folks want to sleep now, you can start doing that. Someone once asked me what a program is for me personally. And I thought about this for a while, and I think there's many ways to cross-cut it, right? It sounds very pseudo-philosophical if you say, programming is about something. But at the end, I arrive at 2 things in particular. One is transformation, right? You transform the raw data, or translation, right? Or translator, basically translate into the correct format. And of course, there's also state. And I feel like these 2 things composed together we can use them to derive most of the other concepts we've come to know about. So for example, maintainability, I would say it's transformation or translation cost over time, right? Or familiarity is translation cost for human, right? You want to minimize that. Interop is translation cost for human and machine. Performance is state and translation cost for the machine, etc. This point of view isn't necessarily correct. I don't want you to think that this is the correct way to think about it. But for our purpose, they work well enough for the next section, right? And as a trivial first-level example, in this particular scenario, we're going to evaluate how costly the translation is, or how, if you flip it, how high quality the translation is from the program to the final result, assuming it's the same result. If it's not the same result, the cost is infinite, let's say. Okay, so we're not going to talk about state here, only translation, because functional programming, as you know, like actually manages state pretty well by pushing it to the boundary, so there's not much calculation I would need to do, and it simplifies a lot of these things. So let's say you're required to output a list of students' ages, and I tell you this is 5 students' ages. What do, right? First thing, that's simple, just do this. Okay, in this particular scenario, this is not really controversial. It's very readable. It's very self-explanatory. And this is basically the theoretical best you can get, right? There's nothing simpler than that. And because you literally write down the result and inline it, and everybody can verify this is correct, so we're going to assign this score 100%. So that's our top right there. So the cost of this taking as an entire program is 100%. And on the other extreme, this kind of makes sense mathematically. If you have infinite lines of code, it doesn't matter what the result is, right? It just never returns, aka the quality is 0 because the cost is infinite, right? Quality is 0. So we have 2 boundaries here, 0% and 100%, and all we need to do is find a curve that actually, given a program, tells us how good it is. The secret is there's no such equation. Otherwise, I wouldn't be here. I would be making millions doing other stuff. But let's see. Now, let's say the extra requirement is that we only keep the students whose age is above 10, right? So this obviously becomes more complicated. Here are the things that can potentially go wrong. I would say these 3 pieces underline, right? The loop, the conditional, the condition, and the consequent, right? The body here. And we're going to derive a translation quality score from these 3 blocks and ignore all the other syntax noises and treat it as an AST, basically. So let's just say something that we can all agree on. Well, what's the chance of us writing this for loop age in ages, right? Writing it correctly, first shot? You would say probably 99%, right? Unless you make a typo and catch it right before the program, still 99% before you run it. But it's not 100% because you might loop on the wrong array or something if there's name collision somewhere. Now, likewise, the second block, I'm going to give it, let's say 95%. So 1 out of 20, you get this wrong by flipping the sign or adding an equal when you shouldn't do it, right? And the last one is also 95% because this push operation is always a little bit tricky, and it mutates, and you have to track something above, and then things might go wrong. So all in all, I'm multiplying these percentages together. There are reasons why I'm multiplying instead of doing some other calculations, but I won't explain them now. So if we can all agree that we can just multiply these things together, the final correctness for that entire block of code is 89%. Yeah, chance of getting the whole thing right first shot before you run it. As an aside, what's nice when you have a type system is that, especially a sound one, is that the type's going to cut through every single little block of code you have and prevent you from expressing trivial mistakes, right? Like, for example, accidentally, on the second block, accidentally compare it against a string, right? Or pushing the wrong type into the array, right? So I would say with a type system, we can give ourselves a little bit of pat on the back and say, well, we're going to bump these 2 last value up a little bit more before the first run. And then what we're going to do is we're going to test it, right? Anybody still remember tests? That's a thing. So after you test it, basically, if you see the before and after, before and after, only this metric went up. You are mostly testing on the condition here, right? There's nothing else that can possibly go wrong, and if so most folks underestimate the power of tests here to boost the percentage. Though it's true that it kind of takes more effort to test things, but the bang for the buck is still relatively high. Not as high as, say, just a type system implicitly going and killing bugs for you, but still pretty high. So I didn't bump the last line also because in JavaScript, you might, in this line, in addition to mutation, you might have some proxy or overriding the prototype or some mutation observers. So you're never actually going to get it correct because I can always, as a dev tool, stub it, do something else, and then accidentally mess up, right? So let's say it's realistic in life that the program is going to be 99% correct, not 100%, right? So notice how you look at these blocks independently, right? You will go, this is mostly correct, right? But when you compose them together, you can get a compound effect of the whole thing suddenly bringing down the probability of getting things correct to less than 90% at first. And then we bump it up. This calculation I find is very simple and intuitive and conveniently includes an idea of not just robustness of the code, but also readability, which decreases the more lines you have. So if you have, say, 99% hit accuracy for each line, but you have like 20 line, at the end you still get around 81%, right? It kind of makes sense that readability kind of gets affected. So because you can also think of it in absolute toward the limit. If you have infinite lines, it's not readable. So that calculation kind of makes sense. This is just a trivial proof to do that. So basic economics will tell you never underestimate the power of compound interest. And I would say as engineers, we need to learn to not underestimate the power of compound crappiness of a system. Now, I have a better solution to this particular example, actually. One that will bring the correctness to virtually 100%. And here it is. Ta-da! I'm just going to inline the result. So, this is 100% correct, right? So you might find this funny. We're back to the first example. Until you pause and see the big picture here, that in general, not just for this trivial example, when you concretize, right, and the removal of the unnecessary indirection allows you to weed off all the potential sources. You don't even have to calculate them; they just cancel out, right? And you might say, for example, what about maintenance? Is this maintainable rather than me just writing a loop? And and this is actually a big misconception. This equation hopefully can elucidate. And my question to you is, what gives a better translation quality? Probably, what gives a better translation? A, starting from an absolute correct thing, absolute correct subset of functionality, and make it less robust, but grow it into the new requirements. Or B, starting from a abstractly high overhead, comparatively less robust implementation, and then try to tweak that into your new requirement. Think about that. Right? One realization also, someone said on the internet, dear stranger, said, most complex systems grew out of initially simple systems. You rarely see existing complex system growing out of initially already complex systems. So this is a lot of theoretical mumbo-jumbo. So here's an example of how it actually applies in real life. We just released, again, a new version of Reason React that uses React hooks. Now, React hooks arguably are slightly controversial, but they're undeniably easier to bind, especially for us, because they don't use classes, and classes are non-trivial to bind, to say the least. This is the output on the right from the old Reason React. If anybody even still bothers to open the .bs.js file and look at this mess, and this is the clean code you have here, and this is what a computer gets, and it's like, oh, what the heck? So this is the whole thing for a stateless component. And I want to show you the new one. So here's the output. This, on the right, is the output prettified and re-JSified. We take create element and we turn it back into JSX just for this example through a small Babel plugin. This basically looks like handwritten code on the right? Yeah? And on the left, you don't lose much except the PPX, which makes everything complicated. But in life, you have to give something. And here are the JS output only, old one versus new one. And can you see the difference? Here's a magic move effect. In case that wasn't clear. So no, there was one spring. There was no spring. It's actually a decay. That's a bad question. What's the translation quality of this old code? Who knows? Probably exponentially bad, right? As a matter of fact, as a maintainer of Reason React, I'll tell you I don't know. It seems to be correct so far through many tests in real world, but hard to say, right? What's the translation quality of this new code, right? Both relative, it's a relative metric we're talking about here in this case. What's the translation quality of this new code versus handwritten React, idiomatic React? This is 100%. You don't have to reason about it to say, well, is there a indirection here? It's handwritten code, and so there's lots of side effects that come for free when you think about code this way and you code this way. And the first thing is, if you ask about how this is the output, this is the source. If you ask how this actually interrupts with existing React.js code, you don't really have to think about it and then model the semantics or anything. You open the file and you say, this is a React.js component. It looks like one, it acts like one, so it will work like a React.js component, which is why the new Reason React hooks API, we don't have interrupt because there's no such thing as interrupt. It's one-to-one mapping. This is a social service we're actually doing. The thing is, we often see folks in userland evangelizing very passionately Reason React in their workshop or dojos by starting to explain, here's Reason, here's BuckleScript, here's OCaml, here's Reason React, and by the time they're done, basically they've lost attention of half of the audience already, and nobody's happy with that, right? And with the new Reason React, we're fixing that. So you don't have to be the translator anymore. Your translation is guaranteed to be mostly correct. The translation cost is almost non-existent, so you just show them that the new doc page, and say, well, look, this is exactly what React.js hooks look like, with a few name tweaks to prevent some kind of overloading. And then you prove it to them by showing the output. Records and variant are still a little bit noisy, but otherwise it should look pretty impressive. This is a pattern that we hope that the user libraries can also adopt more. Get rid of yourself of all the wrappers, and you'll find it much easier to convince your colleague when you show them the output and they realize that there's an absolute guarantee you're making to them. Right? All right, so let's go back to our original example. Hopefully you're not too bored. Some people might say, well, that's the beauty of functional programming, right? You don't have to do that. You can just use functions, right? And now that line of code is maintainable, right? This whole code is maintainable, right? Well, no, not really, because just using function doesn't suddenly make your code better. Then every language will be as good as yours, right? As a trivial proof, that doesn't make my code any better, right? The nuances we're missing here when we're calculating this that we didn't take into consideration is that the translation metric is actually transitive. Right, you need to view it as a holistic at a system level. So when you see that keep filter call, you need to drill into that function, calculate the cost, and bring it back and put it here. Right, so the total amount. Right, so this is the old code. This is the new one that you're actually writing. So if you drill down into code, you realize, well, the percentage stays the same, which kind of makes sense, right? You wrapping it in a function doesn't suddenly make your code more robust. That's not true. So if that keep is implemented using a loop, you get the same percentage. But as a matter of fact, the quality remains the same, but in the final translation on the right example, the cost calculation will have to lower the percentage by adding a diminishing diminishing score on the keep, because this is a name that's lossy, right? It's a very lossy name to summarize what it actually does. So there might be naming mismatch, understanding mismatch, and of course there's an extra level of indirection. So it's a readability hit, right? Again, think about having infinite level of indirection. The quality goes to 0 no matter how correct the other pieces are. As a matter of fact, the more you compose, when we evangelize it, we tend to have this naive perspective. The more you compose, the lower your percentage actually becomes. And I think if you think about it in terms of these kind of very simple equation, it actually makes sense. Right? Because the call itself has a cost, so it doesn't matter if the content is 100% correct. Again, if you have a 10-layer, 20-layer, percentage goes down. The fancier the feature, actually, the higher the cost too. Yeah. So, for example, composing GADTs or functors, which do have their use but are kind of abused in user land sometimes, or excessive currying, right? And excessive point-free programming where you have to reify the actual argument in your head, or 2 or 3 arguments, how many, right? It kind of wrecks your score more so than composing simple functions, or even better, composing data structure, which is one of the safest things you can do in terms of composition. So thankfully, we can usually assume that this code is high quality. Why? So why is this code in practice actually high quality? It's not because you wrap it in a function. It's because you wrapped it in a function that's guaranteed to be high quality in the standard library. So when you give this example next time and you say, well, the beauty of functional programming is that you can wrap in a function, you're really just comparing one standard library against another language standard library. It's not doing much, right? It's not very convincing, in my opinion. So we can assume that keep is battle tested and do kind of like a big step semantic. I would say, like, just assume that the whole total is around that value, and you get a higher percentage at the end, right? Okay. Well, this is over. That's enough of that calculation for now. So there are many ways to calculate that. As long as you find something reasonable, you can think about it in a more analytic kind of way. So here's another really good real-world example of probability and system thinking that I tend to not find too much nowadays, at least in the domain we work in. Note that everything I'm going to show here is related to calculation we've done earlier, so we can forget about that now. None of that is going to appear in the exam. So we're going to talk about our build system, buckle script build, BSB. Here's a quick overview, of how a build system works. You have a bunch of dependencies like this, right? And the arrow indicating, for example, that main.ml depends on school.ml. The direction is like that. So school.ml is dependee. And you have to analyze the dependency, right? Drill down and go to the sinks and first compile those, right? Before you compile their dependent. Otherwise, it wouldn't type check. You follow the arrow backward and compile those. And at the end, lots of opportunity for parallelism here, if you saw it at the beginning, right? Like these two can be parallelized, and there's also lots of opportunity for incremental partial rebuild, which is why buckle script BSB is so fast, because when you run the build, it just analyzes the graph and say, oh, teacher.ml is the only thing that changed since last time. These are the only two things I'm going to build, right? And you do it in the correct way. And it becomes extremely complicated in the case of OCaml, but this is a simplified version of it. So two things, right? There's coordination of the dependency graph and dispatching of the partial rebuild, which we're just going to call a coordinator or a scheduler, right? You can think of it as scheduler. And then there's the actual per file, actual compilation using OCaml-C or BSC, right? So two different parts. And let's compare actually with the build system of TypeScript. Nothing against TypeScript. It's just a simplified comparison. We don't shy away from our actual advantages, and we don't shy away from our actual problems, right? So TypeScript does it this way. The watcher is optional, but we're going to include it for us too. First you dirty the graph, right, by modifying a file, and then it calculates the dependency chain, and then for each of these nodes, each of these files, you compile each, right? And the nuance here is that this is pretty standard, but the whole process, the entire thing from the start to to the end runs in memory and stays active. Okay, in memory, as in there's no Unix or anything. You fire up the watcher once and it just runs in the background, right? Kind of like Webpack watcher mode too. So the problem is that sometimes when a project gets extremely intense in terms of number of files or number of, or sophistication of the type system, the type system feature used, you get things like out of memory errors, which are sometimes just not solvable, right? And among other errors that are hard to debug and resolve and even patch on your side. Maybe you can just split a file like that and make sure the type doesn't act up or something like that. And this doesn't happen just to TypeScript. It happens to all the in-memory build systems. This is very troublesome because at the end, what you're going to do is you're going to basically create, in the spirit of Lisp people, you're going to create an ad hoc subset of a bad garbage collector in your build system to make sure that the memory actually stays correct and everything. So with BuckleScript, Bob decided to do it a little bit differently. BuckleScript, only this part is in memory. Okay, only this part, and not even the second part, really. Only the watcher, which is like a node script, like a 200 line or something, is in memory. So what happens is, every time there's a rebuild needed, right? Watcher sees the Unix call, sees the dirty graph computed, and here's the thing: for every file, it starts a new Unix process of OCaml-C or BSC for each file. Right? It starts a Unix process, compiles a file, and then immediately kills a Unix process afterward. So what do we get with that is that you get an obviously correct garbage collection system, right? You have basically no memory leak and if you even leak, the memory leak from the compiler is going to last, like 1 millisecond or something like that, right? So you don't actually leak because the garbage is all collected by Unix system, which is battle tested, right? So deferring to the correct pieces here. So the probability of getting out of memory with BuckleScript is almost non-existent, except if you have that one single file with like 10 million lines of code, but don't do that, So this is a part of working smart. We have. You also separate the bug you have from these two into like a boundary, right? So you have the bugs that's from the watcher or the dirty graph, and you have the bug from the compiler, right? Instead of having n times m bugs, you have n plus m bugs, right? As proper separation. That's all it's doing. And why can we do that, though? Why don't we also go in memory? And why does other build system have to go in memory? Well, that's simply because TypeScript's actual compiler and build system is written in JavaScript, so you can't actually start a JavaScript process and then kill it and do that because the overhead is too high. And for us, BuckleScript's compiler actually starts extremely fast. This was very good engineering from the OCaml folks. Start a build system fast, and you kill it fast, and that's why we get to have this kind of thing. And when you do this, the intermediate file also serves as an obviously correct milestone, and you don't have to do time stamping anymore. So that's pretty cool. Anybody has seen a bug from BSB before? I don't know. Like I've seen like one. Just saying. Like these architecture definitely do work out. The OCaml compiler's complexity is non-trivial. It's around like nowadays like 60,000 lines of code. How are you going to verify that it doesn't memory leak or do some shenanigans, right? To be fair, it's pretty high quality engineering, but still it's 60,000 lines of code. Now, why do I talk about these things? Why do I ask you to proceed so cautiously and conservatively and analyze the risk before doing something? This is not usually what the front end does, right? We just do gung-ho and ship an app and then fix it later, maybe not. Well, slight jab, but why do I ask you to do this? And this is the actual point I want to get through to you folks that I think is the most important thing to remember. But before that, I'm going to go into a tangent. So this is Assassin's Creed. I don't actually know which version it is, but I remember back then when I was younger, I played one of the earliest Assassin's Creed. And one of the things they used to like tout in like a demo video is that, that was very early. That as the assassin walks through the crowd and hide himself, he just bumps into people, and I push some people away, and then people give him dirty looks, and it's like, what the hell are you doing? And these kind of things actually doesn't modify, as far as I knew, it doesn't modify the game's functionality, right? It doesn't. It's just purely there to add delight and funness to it, right? And video game, which seems to be a cousin of ours, seems to like to excessively add these kind of details, these kind of delight, because their goal is to have you have a fun time in an immersive world, right? And it's also kind of amazing, for example, in the newest Legend of Zelda, the objects just interact with each other randomly in like a very messy dependency chain you can't really reason about. But if you throw a bomb, you can like glide on top of it. Spoiler alert if you don't know that. And this also applies to not just like AAA titles, right? This applies to indie game. There's like, I don't know, like one developer for this. Anyway, this is not rare, right? You see the cat interact with each other, and if you're a front-end programmer, you're like, well, that's going to be 4 independent React components, right? No, they just work together. They have a messy, mutative, imperative dependency relationship between them, right? So this is pretty mesmerizing here. I should credit the game. I can't find it anymore. Sorry about that. So these things add the element of fun into the medium. And my whole point is, on the engineering side, I still remember actually mentoring someone and telling him to remove the gratuitous kind of crewing he was spreading everywhere in the code base. And the reply he gave me was that, but it's so fun. Right, and I kind of feel bad and conflicted at the same time because, to be honest, we're here because we think that Buckle Script and Reason are valuable to our code base, of course, but part of us really can't deny the fact that there's also an element of shininess and fun in the stack we want to play with. Yeah? And it sounds like, if I don't find a code shiny or fun, I'm not going to want to make a fun product in the end, and my philosophy kind of carries over, and this is not how it actually works. Please remember this. This is not how it actually works, right? What we're trying to convey here is that if you spend all your translation and complexity budget, the keyword is budget, upfront on the engineering side, that you don't have any budget left to craft these actually highly complex interaction in the end user product. If your whole code base is as messy as this is visually, right, from an engineering term, then you don't get to create these kind of games anymore. What you end up creating is some very rigid, static-looking, barely dynamic PDF rendered on the web. That's what I would call what we're doing right now sometimes. So if you phrase it in terms of budget, I think this is a much more productive and constructive way of looking at things. Sometimes you cannot carry your philosophy through the whole stack. There's going to be a trade-off, and you're going to decide which one do you value more. It's not like everybody can have the cleanest, most beautiful, delightful API, and I'm going to make my terminal say hello to me in the morning when it builds or something like that. This complexity that you spend here is extra thing you cannot spend in the end app, right? Our goal with Reason, some people ask us, what's the mission of Reason? The mission of Reason is to make great end user product. So 3 things here. First, it has to be great. We didn't make all these things so that you make the same thing that you would do with JavaScript, right? It would be just extra overhead. Yeah, it has to be great, and thank you for attempting that. Second thing, it has to be end user focused rather than end developer focused. And I say this at the end because now I think you understand what it implies to target yourself toward end user versus developers, right? The trade-off you're making here is against yourself, whereas if you're creating tool for developers, you're just optimizing for yourself, and it's all the same target audience, so there's no discrepancy, there's no trade-off need to be made. And we want to make that trade-off to create really good end-user product, right? And I say product, also not library, because there are lots of nuances. Like product is what gives you a solid footing in a company, right? This is what the manager will say, well, this is good. We're going to pay you to do this now, instead of you creating libraries during the weekend using Reason and wondering why this is not still taking off or something like that, right? You got to be creating products. You got to work backward with the smallest translation costs toward your real app, and then go up, not the other way down. The other way down is how some other functional programming languages don't take off, and we don't want to be like that. So it's an optimization problem, right? And we're optimizing, for a product instead of engineering. And I trust that you all will spread the word and be mature engineers to realize that sometimes you have to compromise your own experience. In an ideal world, we don't. So the theme, to conclude, the theme of this conference this year is on the road to production. Unfortunately, I'm being a really bad role model here. Until now, I've talked about nothing but high-level pseudo-philosophical concerns, right? So I kind of wasted our infra talking budget, right? Unfortunately, the talks following this one will compensate for my waste of budget by mostly talking about products, mostly. So we try to aim for that 20-80 split, right? 20 time talking about the infra, 80 time talking about your actual product, which is why you're even here in the first place, right? Do the product, hopefully. And I would like you to, do the same. So when I come down the stage, and I like you to tell me about your experience with Buckle Scrimmer and Reason, of course, but I want you to also tell me what your project is doing, right? Which company you work for, whether it's high quality, whether you're proud of not just the code base, but the final product, once you've done all this kind of analysis, right? I'd like you to care transitively, holistically about the entire product and make the right sacrifices in the right place to achieve a great product so that in the end, Reason can actually take off and take off in an honest way. So this is what's going to distinguish us among other communities. Have a great conference.